this is what the language is. Write the partial fraction decomposition. So we're trying to break this down into the smaller partial fractions. So they're calling that a decomposition, right? Well, step one is always factor the denominator. Okay, and that's a pretty simple. Most of the time, they're not trying to challenge you with a factoring problem here, so it should be a pretty easy factor, right? X squared minus x minus 6 is x minus 3 times x plus 2. Okay, so the partial fractions will be some constant divided by one of the factors. I put x minus 3, plus another constant divided by the other factor. Right? And it doesn't matter which term you write first. It could have been x plus 2, then x minus 3. Right? But our job now is find the numbers that go here, and they will just be constants. Okay. Well, in order to add fractions, right, I need a common denominator. Right? What will the common denominator be? It'll be the original denominator. So what's this first fraction missing that the common denominator has? It has an x plus 2. So multiply by x plus 2 over x plus 2. What's the second fraction missing that the common denominator has? X minus 3. So write it in here. X minus 3 times x minus 3. Okay, now they all have the same common denominator. That means the numerators are equal. Right? If I added these two together, then it would just be the same denominator on both sides and all this added up. So now I know that x plus 7 equals a times x plus 2 plus b times x minus 3. Okay, now we're not. You're going to leave the left-hand side alone. Don't mess with that. But try to simplify what's on the right. Combine all the like terms that you can. So this will be x plus 7 equals ax plus 2a plus bx minus 3b. Right? That's just distributive property. Now let's get our x terms together. X plus 7 equals ax plus bx and 2a minus 3b. And I could even take one more step. I could write it like this. X plus 7 equals a plus b in parentheses times x plus 2a minus 3b. Okay, now if what's on the left-hand side equals what's on the right-hand side, then the coefficients of x have to be the same, right? If there's only one x over here, then there's got to be only one x over here. So what does that tell you about a plus b? A plus b equals 1, right? Make the equation between these two. A plus b equals 1. Okay. Now, there's a constant term on the right, right? Well, this represents the constant term on the left, the 7. This represents the constant on the right. So in order for what's on the left-hand side of the equal sign to equal what's on the right-hand side, the constants have to be equal. So it must be that 2a minus 3b equals 7. So that's a system of equations. Two variables, two equations. Solve any way you want. You could even use matrices. What method do you think you'd want to use here? Say, Justice? Okay. Which one do you want me to multiply to set up elimination? Okay, if I multiply this one by 3 and I put the result here, now I've got 3a plus 3b equals 3. Okay, now add them up. 2a plus 3a is 5a. The b's cancel, and the right-hand side is 10. So A equals 2. Okay, that's 1. Now you need the B. Yeah, plug it in anywhere, probably the first one, right? If 2 plus B equals 1, then B equals -1. So the right numbers, when we made our partial fractions here, it should have been a 2 here, and it should have been a -1 here. And that is what we got. That was correct.